So let's look into what is a magnetic field line and how this helps in studying of magnetic properties and other things related to magnets, right? So the entire chapter depends on magnets and its relationship with current. So the best way to approach a study of magnet is through help of magnetic field lines. So what is the fundamental idea of magnetic field lines? It's an imaginary lines or line actually, which helps us to study magnetic phenomena. That's the simplest way I can put it across. So what is the actual definition? It is the path along which a hypothetical free north pole would tend to move. So I spoke of monopole, right, in a video back also. So in that I spoke about a single pole of a north, if not south. A single pole, which does not exist, but theoretically say theoretically it can exist. We can imagine. That's what I mean. So what this statement means is simple. If I have a north and south, some magnet like this kept in this way. Say I keep the imaginary north pole over here, monopole, only north pole. What happens? Well, like if you have a north in front of a north, what will happen? Say this is fixed, they can't move. And this is also fixed, they also can't move. So what will happen? This will obviously get pushed by this north and it will get pulled by this south. So basically it will take a path in this manner, is it not? It'll just go, it will accelerate towards the south basically. So if I had kept it over here from this touching this end, it would have been a straight line, something like this. And this would have accelerated this way, right? Makes sense? So if I had to write the direction for this line, the imaginary free north pole would have ran in this direction. Make sense? It's same as having a test charge, if you remember, a positive test charge. If this was a positive end, and this was a positive test charge, and this was a negative end, which was fixed. The test charge would have ran from positive end to the negative end. Same way, right? Now, if I have a single bar magnet, if I happen to keep the free north pole over here, it would have taken this path, running from north end to the south end. Make sense? If I kept it somewhere over here, it would have ran this way. It would have taken this path. Yes, it looks weird, but yes, it would have taken this path. That's what they mean. So if you happen to keep a free north pole at any of these points, it would have taken this path. Okay, so we are imagining that we are leaving the free magnet from this end. So, and watching it move, it will take this path. Okay, that's what the field line means. So I have small question. Which end is the north? So I have a bar magnet, sorry, not bar magnet. This is known as horseshoe magnet because it's shaped as an horseshoe. So, and I've drawn a single magnetic field line. So the question is, which end is north and which end is south? Please pause and think over. So clearly from all of this pattern, we can see that this is a line taken by the free north pole, is it not? All of these magnetic field lines are taken, the part taken by the free north pole. That's what it means. So this thing is running away from this and going towards this, right? These two ends, the magnetic field line is running away from this and going towards that. Clearly, this has to be south and this has to be north. So this end is your north end. Okay, I hope you guys understood. It's a very simple concept. Remember, it is a free north pole that is running around. Like how you had a positive test charge, if you remember. I hope you guys do. A unit positive test charge running around, and that's how we study electrical field lines. Here, we study magnetic field lines with a free north pole. always remember what is the test pole. Okay, and you will be able to understand a lot. So remember that it is a free north pole that is running around. Okay, very important as for us to remember.